IIB is the only professional body exclusively dealing in bridge engineering. Spread out 33 state and local centers with about 7,000 strong member force, and 169 institutional members, IIB has created laurels for the country. It has also published 29,200 pages of technical literature now, which is available online for the members as well. And IIB holds an outstanding bridge national award competition, very frequently, regularly, basically. Yeah. So with this introduction, let me go to the next part of the event. Ruhi, next slide, please. Ruhi, next slide.
Yes, sir.
Your screen has, yeah. Yeah. So let me introduce our DG, Director General of IIB, Engineer DG Divte, who is graduated in Civil Engineering from College of Engineering, Pune in 1974. Through 1975 UPSC exam, he joined Indian Railways Service of Engineering (IRSE) as Class 1 officer and retired as Principal Chief Engineer of Indian Railways in 2011. During his service, he worked on many important railways infrastructure projects. He occupied the important post of Principal Chief Engineer, Northeastern Railway and Southwest Railway, Director, Board Member of Konkan Railway Corporation, Chief Engineer, Konkan Railway Project, Chief Project Manager for Tunnels of Mumbai-Pune Expressway, Project Director of Katra to Loli portion of Udhampur, Baramulla, J&K Railway Project. Recently, he has worked on Mumbai Metro 3, 33.5 kilometer long, fully underground metro construction projects as CGM. So we have a great support of DG for all these lecture events happening regularly. Let me introduce our president. Yeah, our president, Shri Engineer Vinay Gupta, is a civil engineer from BITS Pilani, 1983 batch, and director and CEO, Mrs. London Consultant Private Limited. His specialization is into bridges, flyovers, underground and elevated metro structures, precast buildings, 275-meter tall chimneys, etc. He's an active member of various code committees of BIS and IRC. His contributions include preparation of IRC SP 65, segmental bridges, IRC SP 71, precast pre-tension girder bridges, etc. Receipt of several awards from IEI, IBC, and UKIERI. He has been lecturing as a guest faculty in IIHE, CRRI, CIDC, ISDA, DPC, etc. Engineer Gupta is an All India President for ICI as well as Indian Institution of Bridge Engineers. And with the great support of our DG and President, we could really achieving good heights and developing IIB to the further level. Yeah, do we next slide, please? Now let me introduce our today's moderator for today's special lecture series on CRUX in erection and launching of cable supported bridges. Engineer V.N. Hegde will be the moderator for today's special lecture. Engineer V.N. Hegde presently is the Chief Executive Officer of Spook Consultants and former Executive Director of Gammon India. Is a senior professional with a rich experience of over 3.5 decades in construction sector in the areas of design management, technical management, site management, project management, and contract management of highways, bridges, energy structures like chimneys and cooling towers, environmental, marine, and hydraulic structures. He is a recipient of around 9 national recognitions in addition to an international prize of various institutions, IRC, ICI, NDRF, IBC, and IIBSC. He has more than 140 publications to his credit and is a member of various IRC and BIS committees. He is also a member of TG 10.1 of Federation International du Béton, which is Special Task Group working on FIB model for 2020. Apart from being on technical board of ICI and academic board of SPCE, Sardar Patel College of Engineering, is also a fellow of Indian National Academy of Engineering, FNAE. So with this brief introduction, may I now request our moderator, Engineer B.N. Hegedeji, to take over the session from here onwards.
Thank you, Swapnil. It was not a brief introduction. I think all the introductions together, it was a mammoth and a vast introduction, I should say. And I thank you, Dr. Gopal Roy, as well as the Vinay for, inviting me to become a moderator of this very, very important and contemporary subject of the cable-supported bridges, erection as well as the construction. Among the panelists, I'm very happy to see that some of the stalwarts and my friends are on the virtual dais today, virtuous dais today. And among them, there are the two very close friends of mine are the panelists, Mr. Jatkar as well as the Atul Bobe. I would like to introduce them. And if Rui can help me in putting forward the slides forward. Jatkar Saab, I put it as an evergreen Jatkar Saab, in fact, and all of you are able to hear, right?
Sometimes yes, absolutely.
Jatkar Saab, evergreen. Jatkar Saab is from the University of the Pune. He has done the Masters in Structural Engineering. He joined Gammon in 1980 and has an extensive experience, nearly 4 decades of experience to be precise, in permanent structure design and front-end engineering as well as the temporary structures design. He was an executive director of Gammon India Limited and is presently an advisor to technical in Gammon Engineers and Contractors Private Limited. He is a contributing author to the book, a very, very important book, in my opinion, for the temporary structure designers as well as for the constructors too, Bridge Deck Erection Equipment, published by ICE as a member of the working group WG6 of IABSC. I had an opportunity to work with him for almost 35 years. And that was a memorable time, I should say. Apart from just engineering, we also spent time in other social and other events too. It is always memorable to me, and I always enjoyed his company. Next panelist is ever smiling, Atul Bobe, Mr. Bobe. I always like him, like even in the photograph you can see he's a very smiling, and he's always smiling gentleman. Sometimes people tell me also, but I recognize that quality in Mr. Atul Bobe. He has done his post-graduation in civil engineering from one of the very the recognized institution in US, that is Ann Arbor, Michigan University of United States of America. He is a managing director of TPF Engineering and is on the board of TPF Group, a multidisciplinary consultancy group, and more than 4,500 personnel it hosts, and has the turnover of around 2,000 crores. Like if you really kept, it is astounding in my view, because if you really calculate the per capita turnover, it is almost works out to be around 45 lakh rupees per person. 4,500, 2,000 crore divided by 4,500 personnel it takes. It's really incredible. And TPF must be doing very well under his stewardship. His expertise include structural design, engineering of buildings, bridges, flyovers, highways, skyways, railways, tracks, industrial structures, sewage system, water systems, etc. These almost all, the aspects of civil engineering. He is also an expert in the design of cable stay bridges, steel structure bridges, using software for design. He has published and presented more than 100 papers in national and international seminars. He is a recipient of PSC Design Award from the National Design Research Forum. And he's also a young engineer. He was nominated from IABSA for the Young Engineer Award in 2003. He's a life member of Indian Roads Congress, Association of Consulting Civil Engineers, IABSC, American Society of Civil Engineers, USA, Indian Institution of Bridge Engineers. In fact, to a large extent, he helped our Mr. MC Bide in really bringing up this IAB to this extent, which has been very ably taken forward by Vinay Gupta as well as Dr. Roy and Swapnil. And that is what is about. I think it's a very, now I'll say it's a brief introduction of Mr. Bobe. Now coming to that today's speaker, Mr. Bassista. I think, can you just go to this next slide? He will be speaking of one of the very, very contemporary as well as in vogue subject. That's the cable supported bridges. He will be talking on the erection as well as the launching aspect of it. It's the most needed the seminar and the presentation. I will tell you why later after the introduction of Mr. Bassista. Bassista graduated from civil engineering from LE College, and he's holds the master degree in construction as well as a project management from CEPT Ahmedabad 2001. He's a specialized in precast segmental bridges, stakeable bridges, high-speed construction as well as the priestess structure. He is also having a extensive experience with over 90 kilometers of viaduct construction. He has worked in several prestigious projects like Bandra Worli Sea Link, Mumbai, Airport Rail Link, Bangkok, Electronic City Expressway, Bangalore, Hindon Elevated Viaduct, Ghaziabad, many stable cable bridges like Atul Setu, that is Arachapra Bridge perhaps, and Basoli Jammu. I remember this Basoli Bridge when we are quoting for this particular job. We had come out with a very innovative solution, but I think it maybe because of the Bassista we lost, he might have given more competitive offer to Mr. Singla. Veera Converse Singhu Bridge, Arachapra, I said, Hatania, Dosania, Soto, as well as the West Bengal. Mr. Bassista will be going to talk about, I told you about the highly contemporary and most needed subject of today, that is the CRUX in erection and launching of cable supported bridges. I would like to say some few words about this webinar before handing over the virtual mic to Mr. Bassista. See, I classify this cable supported bridges personally into the 5 categories. One is the externally priestess cable bridges, extradose bridges, cable stay bridges, suspension bridges, as well as the combination of any of the above. You know, like it could be the combination of extradose bridges, it could be the combination of the cable stay bridges as well as the extradose bridges. It could be the combination of all externally priestess cable bridges, extradose bridges, cable stay bridges, suspension bridges. You know, it could be a hybrid of all. In India, suspension bridges are not popular except for in northeast area where some of the pedestrian suspension bridges could have been done. Even for a small traffic also, it could be there up to the span of around 300 meters. But in the recent past, there's a spurt of burgeoning of extradose bridges. The longest extradose bridges in the world has been constructed in India. That's on the Arachapra, and also the Kachi Dargah is going on. And in the offing, there is MG Setu Bridge, Prayagraj Bridge, Sahibganj Bridge, Dubri Fulwari Bridge, and now Bagalpur extradose bridge. All of them are going to come. So it is very, very important for us to understand the nuances and subtleties of erection as well as the construction of the cable supported bridges. Also, why it is so many contractors as well as the designers are preferring the extradose bridges over that of the cable stay and other bridges. It's because the technology, construction technology for the extradose bridges, concrete extradose bridges, normally is similar to that of the cantilever construction, balanced cantilever construction. Indian designers as well as the contractors have perfected the art of the cantilever construction over the period. It was an organic growth for them to like and adopt the extradose bridges. It is similar to that of, but it has an impact, the visual impact of the cable supported bridges, cable stay bridges. So there's a lot of opportunity when you have a combination of cable stay as well as the extradose bridges, you can have a different visual forms. So the options and the flexibility are available with the designer is quite lot to enhance the visual impact by adopting the extradose bridges. That is the reason Indian contractors as well as the designers like it and that. Also, we are coming out with the guidelines of the extradose bridges as well as the cable stay bridges. It's in the offering. It is in the under the preparation for a long time, but it is the need of the hour. It has to come out as early as possible. If any of the, even I am included in that, I'm involved in that, but it's our responsibility to see that extradose bridges as well as the cable stay bridges guidelines comes very as early as possible, because right now there is no Indian guidelines for designing it. Either people have to adopt the FIB 89 now, that guideline, CETRA, or PTI guidelines. It is a sort of a working arrangement we have as far as the guidelines and the design of external bridges, as far as the cable stay bridges is concerned right now. And there is a possibility of lot of difference of opinions among the designers, because in the absence of the guidelines. So it's very important for us to have the guidelines. And in fact, during the Codal committee discussions, we had in fact invited even VSL. I don't know, maybe it is Bassista who had made the presentation about the cable anchorages technologies and kind of thing and all. So today it's the most needed presentation, in my opinion, in view of the bridge building which is going on in the country. And who else than Bassista who can talk about it, erection as well as the construction of cable supported bridges. With this small introduction on the cable supported bridges, I request Mr. Bassista to take over and make his most sought after presentation. Mr. Bassista, the virtual mic is yours now.
Thank you, sir. Thank you. Thank you, sir. That was very nice of you. I hope everybody is able to hear me well. Firstly, I would like to thank Vinay, sir, who called me a few days back, giving me this opportunity to present here on this very, very respected forum in front of such senior panelists and moderator yourself, sir. You have a large experience yourself. The bridge behind you in virtual background says a lot about your prowess of building such structures. So we have still not beaten it. We will go beyond this bridge as well in coming days. Presently, it's the beautiful bridge, the signature bridge, which has been built under your guidance. So speaking of today's topic, we will look at many different kind of construction techniques that are being adopted for these kinds of stakeable bridges in the country, as well as we will try to look at certain technical aspects of this. So I hope you would all enjoy this journey, and I start to share my screen to move straight to journey. I think take some time, so back and let us enjoy this journey. I hope you all would like it. So if everybody is able to see my shared screen, I would.
Yes, it is visible.
Okay, thank you for the confirmation. So we will begin now. So the content of the presentation I am presenting here today, we will take a look at types of stakeable bridges, different types of decks that are used on stakeable bridges, erection possibilities of these bridges, stakeable systems or the stakeable system, what are being used today, important requirements for such bridges, and we'll also look at the construction series, and then we'll conclude with inputs from all moderators as well, I think so. So stakeable bridges, SR is classified into 5 types. The main 3 types, or the basic 3 types, which are there. The extra-dosed stakeable bridges, which is quite fashionable today in the country because of its usage. Stakeable bridges, which are quite purpose-built structures with longer spans. Suspension bridges, as Hegde sir pointed out, it has less relevance today in our country. It's more relevant only towards certain pedestrian or industrial uses. We would presently, on the presentation, focus on extra-dose and stakeable bridges, for that matter, to keep it relevant to the country. We take a look at the shapes of pylon types of stakeable bridge. So take a look at different shapes. I am covering few here. There are many other shapes as well. There can be inverted Y in place of Y, we shall see. Radial cables connect evenly throughout the deck, but all converge at the top of the pier. Harp shape, quite used on cables are parallel, evenly spaced along the deck and the pier. Fan-shaped, a combination of radial and half this kind of well, where the cables are connected to two opposite types points of the pier. So to see that internationally popular FE. This is the most widely adopted standard today. Acceptance of stakeable system using pre-stressing steels. It is international to beton. Recommendation for stakeable design testing installation PTI, Post Engineering Institute. etc. French Ministerial Commission. This is also in vogue. Recently, there has been an IAPSE bulletin 19 extra dose bridges, which has also been published. So this was also nice to move ahead on stakeable bridges. Types of balanced cantilever bridges. You can see here Girder bridges, balanced cantilever bridges, which were quite popular for quite some time in the country on river spans, conventional way of building these bridges. Variable depth, internal external pre-stressing can be used on these bridges, but they have a limitation of the span. Then comes the extra dose bridges, which are in between. So definitely they have an advantage. They can span a bit longer. There is the stakeables are here treated as external pre-stress, and that is why you mentioned their feature, which is external pre-stress, maximum stress 0.6 FPU. Constant or variable depth is possible, but they also have a certain limitation when it comes to span length. Then comes a stakeable bridge. Virtually, it can go quite long. There are more than a kilometer being involved now for these kind of. Of course, after that comes suspension cable stay bridges, which are suspension cable stay bridge has a no limit. Of course, the survivability coming through foundations and others, which is to be looked at. Constant depth, okay, there could be also variable depth. Cable stays, maximum cable stresses here to PU. Here the supporting the deck. It's not other than it is treated as an external. So of VSI, marvelous bridge, you know it, Veer Kuvar Singh Setu, the name of the bridge. It's the longest extra dose in the world. Bridges at Setu in Basoli, Jammu. You can see a beautiful bridge. This is an example of a stakeable. Karimnagar, recently built in Telangana. It's also a beautiful stakeable bridge.
I think Swapnil, somehow Mr. Bassista is not.
Bad connection, most probably. So
yeah, I think he got disconnected. So let me just.
Oh, he will join back. I'm
yeah,
sure.
he joined back. Yeah, he's there. Yeah.
So this is one of the problems of though, like we'll have to have a strong internet connection. Otherwise, this sort of problems, despite having that also, sometimes there are problems. Yeah, I think Mr. Bassista is back.
Yeah, he's back.
Where did you lose me? Can you please guide me? I was not aware.
At the Veer Kuvar Setu, I think that was the last slide that
Yeah.
Fourth slide.
Okay, I would try and restart. Sorry about that.
Yeah.
To the connection.
We can start from here. I think this is okay.
So as you can see, yeah, as you can see, it is Veer Kuvar Singh Setu, Ara Chapra Bridge. It's a marvelous, longest extra dose stakeable bridge in the world today. So then we move to Atul Setu, Jammu. This is an example of stakeable bridges. You can see a large span there in comparison, starkly showing the difference between what a stakeable can do in comparison to an external terrain. Absolutely necessary to be able. Bridge, another Stakeable Bridge, a beautiful bridge being built in Telangana under construction. You can see the Karimnagar Bridge, also spanning river. Limited application in India, suspension bridges, covered here for reference. This is an industrial bridge. It is a coal conveyor bridge in a hydropower project in Northeast India, built also with a span of around 100 meters. So we take a look at bridge deck types, what kind of bridge decks are being used for these kinds of structures. The main classified girders with slab or steel orthotropic deck. So here is an example of box girder bridge. Here you can see the box girder bridge, a uniform cross section with struts taking the compression from the stay introducing a large tension. So this is a box girder bridge. That's another view of the same. You could see the box girder clearly, how the bridge looks once it is in the box girder configuration. The difference here, another box girder, the difference here, the stays are on the side. So that's also quite sometimes necessary, where you don't have, either you have a 2-lane bridge, then you cannot put a stay at the center, as was evident in the previous slide. You can see here the stay is at the center. That's a 4-lane configuration. It's quite possible to divide the deck into 2 defined carriageways. Here, for convenience, for comfort, or is on site. So stay box girder is relevant. However, here definitely to transfer the force, there has to be a beam at the center of the box girder. Of a box girder bridge construction. So another box girder bridge here, Karimnagar. So you see that was an extra dose application. Here in a box girder, a concrete box girder on a stakeable application. Quite wonderful how a uniform cross-section of a box girder, concrete box girder span a long span of 200 meters as well. So here is an example of a wide bridge. Central stays. So here you can see a cross-sectional photograph of a similar bridge. The external post-tensioning around the strut, recompressing the strut to take the tension from the stays. Quite an ingenious idea. Here is the box girder view during lifting. So it's still the same way on a classical cable stay, uniform box girder. We earlier saw classical extra dose bridge using the similar box girder. Here is a stakeable using a similar box girder for as far as application is concerned. A unique bridge structure, U-girders. U-girder, very difficult to introduce stakeable. Here a unique girder designed by Sistra in Mumbai. U-girder stakeable bridge. So you can see the deck is shaped, stays on site. It's used for a metro train. Here you see the view of the bridge, Y-shaped pylon, and you could use stakeable on this kind of bridge. Also, you can see the application. Below is a busy street, so stakeable is fine. Then we come to more approaches. This has been very widely used deck for stakeable bridges. Here, however, we also use a similar technology. H-beam concrete. Here it is in concrete. Double beam, H-beam, you could call it. Here it is a steel orthotropic deck. This allows you to span more. So, example of stake.
Oh, I think we have lost Mr. Bassista once again. We'll have to wait for him to come. It looks like.
I mean, yes, sir, we can request him to, mute his video so that
Yeah.
he'll get a little bit better bandwidth.
Okay. He has to come back for that, right? So we'll wait for him to come back.
Yeah, he's there. Yeah.
Switch off the video and still make a presentation?
Yeah.
I mean, his video.
He switches off the video, but can he still make the presentation?
Yes, he can. Yes.
Okay, good.
Yeah.
Mr. Kailash. Hello.
Yeah, yeah.
Suggestion for you, in case your bandwidth is
Yes, sir.
low, you can switch off your video, but still you can make a presentation.
Yeah, I am actually on a Wi-Fi, but there is some problems.
Okay, like
inevitable rains in the areas, so it's unstable because of the rain.
I think now we can hear. You can go ahead, Mr. Bassista.
Okay, it is. We could. Do you need me to go back a couple of slides, sir?
No, it's all right. I think you are here. You are here. You go ahead. I think you already explained this. Yeah.
Okay, so
Yeah.
okay, so steel orthotropic deck example here of stakeable bridge where backspan could be concrete. This allows you to go further, increase the span length, further span using steel deck. So that's an example of steel orthotropic deck. Here you could see very clearly that the backspan is on concrete and the main span is starting to span on steel, so that you could go a longer span. We are looking at now, the next comes how to erect these kinds of structures. These require some special erection possibilities. Am I still audible and available?
Yeah, you are. Carry on.
Thank you. Sorry. Okay. So possibilities, we are looking at various erection possibilities of such structures, form travelers, types of form travelers, kinematics, we can see cycle time, lifting frame, we can see the types of lifting frames, kinematics, cycle time. Special kinematics sometimes are necessary. We can take a look at that. Incremental launching, we can touch base on that as well. It's quite a possibility for erection of these. Form travelers you can have in U-girder configuration. So that's a U-girder form traveler in use on a. So U-girder have a top truss or a top beam traveler under traveling form. We will see the kinematics of this kind of form traveler soon. That's another example of HP traveler. The traveler is underslung. So as you can see on the deck, there is no structure, but the entire traveler is underslung. However, this kind of traveler will need all the pre-compression from the existing deck, as well as sometimes taking support of the stay for the construction. Quite a idea. So you could use the traveler, the stakeable for the traveler also. That's a typical box girder formwork. This has been used for cantilever constructions in the past, and now it could also be used on stakeable and extradose bridges, as you can see here from a big one in Hatani. So we take a look at form traveler kinematics. Generally, the traveler will have a few important considerations. There is an important diagram which has to be, which is the crux, which is the most important factor holding the form traveler as the form traveler keeps erecting in cantilever. So you cast the segment. We start from casting of the segment to casting of the segment. Once the segment is cast and various things are done, you put various PT and other stuff taken care of. Concrete has achieved enough strength. You lower the formwork of the traveler. Once the traveler formwork is over, you could move the traveler back, which would move the formwork. Here, the interesting part is, since the formwork is suspended from the top, give you a helping hand to act as cantilever for you to travel the you see that the form has been lowered. Now it has been moved back to act as a counterweight. Once the counterweight is in position, which is the formwork itself, you could launch the main beam forward, and then you could launch the rail beam forward. Once the rail beam has been moved forward, you can move the entire setup to the front. Now we have reached the next position. The counterweight is in position. You could install the tie down that is needed at the back, and you could move the formwork forward. The tie down has reached the requirement for the counterweight, and so now you could again go and take your cantilever. You could cast. This is typical of form travelers. You could adapt a similar scheme for various types of form travelers. There could be different form travelers than this typical one as well. And then you are ready to cast your segment after setting up the formwork again. So typical cycle times with these kinds of travelers could be different for different circumstances, but what we would like to achieve for a faster construction would be as below. So segment with stay blister, reinforcement could take a couple of days, a couple of shifts. Formwork closing, concrete a shift, curing installation of strands could take some time. TT installation and stressing, half a shift can be done quickly. Launch form traveler and setup in half a day. So probably in 5.5 days, you could achieve a segment. But without with the stay out blister, you can have a reinforcement similar way. Close the formwork and concrete. You could have curing, install the strand, lower and launch back, install and stress stakeables. This here is an important activity to get added because of 2.5 days of stakeable. And then finally, you are able to launch the formwork and set up again. So that's 8 days. So presently, you could see it could be 14 days, 15 days for a maximum of couple of segments stay to stay. As the stays are mostly alternating, segments are having stays on such structure. So now we look at a lifting frame. Lifting frames, various types of lifting frames. Lifting frames could be devices. They work also in cantilever. They lift the load in cantilever. So various types of lifting frame. The principle remains the same. There is a top truss, which is capable of lifting the segment at the forward cantilever and then attaching it to the completed deck. So here are a few examples of box girder lifting frame. That's an example from a very large lifting frame. The segment weight on this job itself about 400 tons. So that's a large lifting frame. So as you can see, lifting frame, we can look at kinematics. Unlike the form traveler, it does not have a formwork which could be slided back or forward to act as a counterweight. Hence, such lifting frames would need a counterweight of its own. Many lifting frames are designed without counterweight as well, but the stability check of such lifting frames are very crucial to ensure they are safe. So we take a look at kinematics here. It's quite a simple one. You activate the lift-off jacks, activate the lift-off jack, free the rail beam. You could walk the rail beam forward. This could be done in various stages now. This could be 1 meter at a time. Then you lower your lift-off jacks such that the lifting frame is lowering onto the rail, and you then launch the lifting frame over the rail beam. By moving in these steps, you could achieve the launching of the lifting frame from the rear position to the final position. in which case you are now ready to take your tie down, that is installed down, and then you are ready to lift the segments in the cantilever to continue with construction. So here, important, a quicker method. Of course, you could see immediately it takes a lot less because the segments are precast here. You're not into in situ construction like form travelers. So here you would spend a total of 1.5 days or 3 shifts for a non-stay segment, and then about 3.5 days for a stay segment. So totally what you achieve on a form traveler on a 14 or a 15 days time, you could achieve probably here on a 5 days or a 6 days period. But segments have to be precast, and also the segments have to age. So definitely the age of segments have to be considered, which has to be approximately 30 days for precast construction. So here we take a look at a very special kinematics. Then you come to certain bridges where there are delivery constraints. Access is an issue. So you come up with a very different way of building such a bridge. Here, an example from Canada, where the river is frozen for most of the time. So you cannot supply the segments for such bridge from the river. Also, entry into the river is banned. So here, the idea is to supply the segment at one location under the on the pile cap. So here you could see the segment has been supplied under the pile cap in the shadow of the bridge already being built. There are under beam trolleys that lift up the segment. So this view, you can see the under beam trolley has lifted up the segment. This trolley is capable of traveling under the bridge with the segment suspended and is able to deliver the segment to the front lifting frame. For lifting frame, it is the general idea of picking from ground, but this segment has been delivered by under beam trolleys, which help the lifting frame, which help the segment to reach its destination. And this is the segment is handed over to the lifting frame, the special lifting frames. The segment is brought forward and it is attached to the structure. So that is also quite a special application. These could be integrated into the design. We are looking at now orthotropic lifting frames. The working principle remains the same. However, here the segments are steel, so steel beams or something. They are bolted, and the construction is done modular construction. They are prefabricated also in a steel fabrication facility, brought to site, launched forward, connected the same way. Here, the interesting part is that these beams can be delivered from the back. So there you see an example. The steel beams are, you can see on the deck there, the steel beams are parked, ready to go. These beams are already parked, and the traveler there will always use these beams to launch forward. So in such cases, if I'm launching time cycle, we have to launch the lifting frame to do the eye girders bolting, combining them with the existing deck. Shutter fixing, you have to steel orthotropic, you have to definitely concrete the deck. You could use precast panels. However, in this case, is a concreting operation. So you have to concrete it, you have to achieve strength. So probably a 7-day cycle, you could proceed with a segment. However, point to be noted, these decks could be anywhere in the range of 11 to 14 meter long, comparative to a concrete stakeable bridges or extradose bridges, where the deck pieces are 3 meters box girder pieces. This is another very special topic, incremental launching of stakeable bridges. Stakeable bridges are launched incrementally. Here, an example of a very famous bridge, Milieu Viaduct in France. However, this is very special application, and it's not something that has been adopted on a production basis regularly. So here, the deck was launched prior to launch the pre-car and the deck was suspended and the launching continued forward. In India also, there are some examples. Here is an example from Ajayhat project in Westall, where the deck is launched incrementally. Then the deck is supported over temporary piers presently before the stays will be finally suspended, taking the deck load, spanning the complete span and removing of the temporary piers below. This has been done a special application for the railways. So we move on to an important topic, stakeable system. What stakeable system should be or could be used. There is an example of the stakeable system. So there are various components, but the arrangement remains the same. Stakeable system is nothing but a cable that is locked at both ends. The both ends could be one end on the deck, one end on the pylon, or both could be on both sides of the pylon, in which case you need a saddle to straddle the pylon. Anchoring component, you could see from the top, we could start from the first topic, which is deviation. So vibration and deviation load control. There is a bottom item. Anchoring component, load transfer to the structure. We have to have a anchor nut to adjust the tension force. There's a main tensile element, which is strands, the pre-dressing strand, which carry the load. There, of course, a special requirement, corrosion protection as well as encapsulation. There are on the encapsulation, there are various levels of corrosion protection requirements. These are exposed to environment, so definitely you will need a high level of corrosion protection. These are galvanizing and as well as PE sheathing. Protection at deck level, you have to make sure that plastic is not exposed to vandalism. So definitely vandalism, fire, blast, accidents, incidents could take. So there is an anti-vandalism pipes needed. And there are various other items that we see in the next step. So here you could see typical stakeable arrangements. So there is anchorage. Then there is individual encapsulation to provide water tightness. You need an anchorage. And there is a sheathing, sheathed strand. There's a damper here visible, which is cable movement control with damping system. That's an inbuilt damper. Different dampers. Yeah, we will see in the next few slides what kind of dampers are there. Anti-vandalism pipe, of course, as we said, we need to protect up to a certain area to make sure that normal incidents are not affecting the fragile nature of this HDP. Low drag coefficient, high aeroelastic stability of these HDP, very special HDP pipes. Here we see multi-barrier corrosion protection system. So as I was saying, that's a bare strand that we use. That's the main tension element, and coated with galvanizing, wax service, and finally PE. So here that is how you protect, provide and corrosion protection on such system. Anchorages you could get in various types. So these are anchorages, special anchorages for stakeable projects. Here now a pictorial view, you could see actual pictures of these components, how they look. That's a strand, as we said, the main tension element. Of course, you can see the galvanizing. Then there is wax filling in the interstices. And then there is a co-extrusion of HDP. Anchorages, that's a live end anchorage with an adjustment possibility. Here, lock nut, we will see how this lock nut functions. That's a dead end anchorage. That's only for locking. You need guide deviators, tension rings. These are to make sure a certain amount of deviation only enters these anchorages. As I said, if you have end-to-end anchorage in the deck, then at the pylon you will need a certain deviation. Either you could do it with a pylon link unit, that's a steel transfer link unit embedded in concrete in pylon. There could be a saddle where the strands will straddle over the pylon, and one continuous strand will travel from one end of the deck to other end of the deck. HDPE pipe, as we said, this is a special HDPE pipe. So that's also one of the components. What we see here is how a pylon will straddle with the help of a saddle these strands. So here you see a pylon cross section cut for view. Saddle is placed inside, and then there is strands entering from one end. There are special devices to go and move towards the other end. As you can see, various patterns available in the middle. View here is a inverted teardrop shape, which provides the friction inside the saddle at the pylon location for the stakeable to be stressed. Now we come to important technical requirements for such bridges. Geometry control, construction considerations are important, quite important topic. What is geometry control? Construction drawings will show the geometry of structures in an unloaded state. Real structures, however, will deform under applied loads, so self to reinforced loads, live load, etc., depending on construction method and sequence used. Hence, to a structure built strictly to geometry described in the construction drawings will have final shape differing from the geometry shown on those drawings, because you need to account for all these construction stages. The purpose of geometry control is to assess the applied load and the chosen construction method and sequence to propose correction in order to achieve the shape as described on the drawings. So geometry control can be broadly structured into three parts. We start to be a bit more technical from the photographic here. So theoretical alignment, stage by stage analysis, construction stage. So in a bridge, theoretical geometry describes horizontal, vertical line, super elevation. Also known as a theoretical alignment does not consider construction method and sequence. The theoretical alignment is target geometry. That is what is the bridge that we wish to. Stage by stage analysis, known as pre-camber calculation, assess these various deformations of the bridges due to load, construction method, construction sequence. This is done by virtually building the bridge with the help of finite element design software according to proposed construction plan and by applying the loads acting in various stages of such construction. Deformations of the bridge are calculated for each construction step. Aim is to define the required vertical and horizontal camber of the bridge in order to achieve the theoretical alignment at the end of construction. It is important to note that this theoretical alignment is only for one particular structural and loading state because it is specific to that loading state. Variation of loads or construction sequence changes the deformation and hence result in a different camber. So furthermore, the most of the construction materials will time-dependent losses, time-dependent deformation, even if loads are not changed. Hence, the theoretical alignment also on such bridges can be achieved for one point in time only. So it is very important for the designer to define his theoretical alignment in terms of time. He expects the time to be at the end of construction or years or 5 years into the life of construction. And accordingly, these things have to be worked out. So for working of this, we cantilever is constructed first without camber. Here, a case is presented where the form traveler is constructing this deck. Casting curve is equal to the theoretical alignment. That means that for each new segment is cast against the deflected cantilever end. So at this stage, all elevated elements in static are activated with original inclination at the level following deformation of elements in previous stage. So here you see a deformed structure being built quite away from theoretical alignment in sophistic, but it records at every stage what is the camber that is happening due to these deflection at the node. And these are stored for later use. Once this is done, the camber is calculated. Camber is basically fixed components, deformation, rotation in Y and Z direction. However, we are more worried about the vertical camber because deformation in horizontal direction, torsional direction are usually small magnitude because there are not differential in horizontal direction, keep limit, and hence it is of little concern. Stiffness is high on these structures. Camber is calculated by multiplying deformation values of the digital line by -1. So there will be one stage back so that you can provide the camber. It is generally preferred to have a hogging bridge alignment, better drainage, driving comfort in slide. Hence, if long deformation due to creep is downward, the camber is taken from the deformation at 30 years and creep results in upward deflection. Camber is taken from deformation after completion of construction. Pre-camber is then added 2 deflections at every stage to obtain a control line for every stage. In reality, bulkhead of form traveler is set to theoretical pre-camber because it is to achieve the theoretical alignment at the end of those stages. So here, once it is done, this is confirming that finally the rule became that has been introduced, the deltas that we are introducing at every stage. We are now able to match the theoretical alignment at the end of construction or at the end of a defined time by the designer. So that's the control line where the theoretical alignment plus deflection plus pre-camber has been taken into consideration. And that control line is of maximum importance for construction of bridges. So you can see the sag, uneven connection of free cantilevers. The idea is to provide pre-camber on the bridges. To pre-camber the bridge, we need to calculate deflection, deformation of bridges, creep, and deformation, permanent load, shrinkage, time-dependent strain. It's in unloaded condition at constant temperatures, pre-stress losses, draw-in relaxations, friction losses, construction process. This is very important to define at that stage what would be the construction process and at the actual chronology of construction. Materials, it has to be defined what are the material and temperature effects will be. So cast-in situ segments and precast segments will have a different pre-camber. So you need to similar principle, different method of construction. So you would arrive at a pre-camber value on that basis. Finally, is what we arrive at is a stage-by-stage construction. Stage-by-stage construction, kinematics to be included, stage stressing sequences, typical representation here for a stable project. We have more in detail the construction sequence and stages. To come up with deflection for various stages of construction, that's a tree for deflection tree. It is important that this to be considered recam as well as deflection, time related, time and load related deflections. So on that basis, once this is worked out, you also have the deck and pylon coordinates to be considered. So construction is important to consider the deck and pylon coordinates. They are always in dynamic state. So these also need to be carefully calculated, as well as the length of stays and length of angles of stays need to be.
Hello, I think Mr. Bassista has gone off again.
Yes, so
Sorry for the interruptions, all the participants, because it is not in our hands. Unfortunately, we'll have to wait for Bassista to come back now. I hope Mr. Bassista is coming back. Deepika?
Yes, sir, he is joining.
Yeah.
He joined.
Yeah, Mr. Bassista. Hello?
Okay.
Mr. Bassista, you are
Sorry.
to unmute.
Yeah. Okay, fine. Carry on.
I unmuted. It's okay
Yeah,
now?
yeah.
Okay,
Please,
thank you.
carry on. Yeah. You can go ahead. Hello?
Yeah.
Yeah, you
Sorry,
can go ahead.
my
Yeah.
slide got stuck.
Yeah.
Yeah.
It's not moving, is it?
Okay, so geometry control, stress. No, now is fine. I think
Okay, fine.
see. Okay, so geometry control and stressing. So as you can see, the stage stressing sequence, stay force at every stage need to be also established along with the deflection tree. That the Christmas tree, construction sequence, stay forces, everything needs to be monitored. In the world of technology these days, you have quite a lot of support. So here is an example of how software can help you for geometry control of a bridge. So here is a design software that can help you, Geodes. So you could model the bridge in this particular software. It can help you through the construction of this bridge, whether you go for precast or in situ. You can use a geocon. And finally, you could use SMCon for the erection of the bridge, which is geometry control. So here, software, a single platform could move between all the three stages, seamlessly connecting all the three. So this helps you in integrated construction of this complex bridge and take control over the processes which are otherwise probably in different software or different worksheets or different platforms. So these could be integrated. So we come to certain important considerations that we have to do on such bridges. So survey control points are very important on such bridges. So definitely a defined survey control points need to be carefully established at the start of the project, and those need to be referenced for every activity, for taking of survey and reporting of the survey. So here is an example of a survey control point, and then how it should be set on a bridge deck. So on a bridge where there's a central stay, you could offset the center line point for visibility. And you can have more control points for many people would like to have control points at the bottom of the soffit also. This could be done for very high variable depth segments with height of 7 meter or 11 meter or more. We can adopt to that. Special stay for the stay segment, which is a special segment. You need also survey control points on the stay hardware, which is the guide pipe and bearing plate, because you need to align them during precasting of the concrete. So the relative positioning of segment and stay guide pipe is very important and crucial to take care of. Temperature effects. So in general, there would be a large impact of temperature on the vertical gradient. So in balanced cantilever bridges, the relative variation of deck levels between early morning to noon will show significant difference in survey reading. So it is always recommended early morning to the thermal effect or thermal bridge movement of the bridge could be neglected if surveys are always taken early morning. Survey towers in the yard should be constructed in concrete, preferably to avoid large deformation and movement. When exposed to sunlight, they must be covered to make sure there is less and less movement, less and less errors creeping into the control of geometry of these structures. An important consideration is also, as per design, that such structures have to build one segment out of balance. Mostly erection is also done mostly one segment out of balance, not possible to erect it exactly at the same time balance cantilever mode. So this is also something which needs to be checked during surveying or during execution of such large bridges. So now we come to what are the construction sequence. It's a large, vast topic. So we are choosing one construction sequence, which is as many others. Pier construction, that's a normal stage. You have a pier table construction. Pier table could be in various ways. This could be precast, this could be on bearings, this could be integrated connection. This is an example of that integrated connection. Once the pier table is done, you would start with the pylon construction. Various stages of pylon, as you can see, pylon is constructed. First is the inverted Y-shaped pylon. So you meet both the Y ends. Start with the vertical positioning of the stakeable saddles. Final view of a completed pylon here. At the pylon, we have various configurations are on display. We start from the left. Here, the saddle is installed in the pylon. Saddle could be supported on steel frames adjusted for target coordinates. These need to be monitored and positioned onto the pylon. Pylon link unit, as we said, this is a transfer unit rather than the strands crossing from pylon. Here, steel structure or pylon link unit do the job for you. And in a typical case where you have a pylon where you are having no saddle, but a dead end anchorage or live end for that matter could be also positioned. We have the crisscrossing of the stays. Fixing of guide pipe bearing plate in deck. This you need to do at some stage. If it is precast, you do it in precast. If it is manufactured segment steel, you could do in the steel factory. Direction into the main beam, 2 pieces of stays or a single plane of stays. Direction into the main beam, as I said, above for open end, open section in steel, no stressing. Inside the box section in steel or concrete. Below for solid section in concrete. Here eccentrically into the main beam. This is a different cross section into the cross beam in steel or concrete. Below wings, mostly this method. Inside the deck, this is interesting to come from the center of the center stays inside the deck. Mainly adopted extra dose span bridges. We now have example of cable stay bridges using the same. So lifting frame in this case, planning or taking as an example. So lifting frame must be assembled in various You need a crane for erection of lifting frames onto the deck. So here the lifting frame and the lifting unit, in case lift unit is employed, then is assembled on the site. Very important, this is quite a dangerous equipment. Around the world has been toppling as well as failing. So it is very, very important to have a very good for use. Procedures must be well controlled, explained to site people. Mostly these frames work in cantilever unstable conditions. So the measures on such equipment 100% explained, checked, inspected before handing over for use. So the frames are commissioned. You could start with stage by stage construction, cantilever construction in this case.
Again, I think we've got a problem of this interruption because of the instability of internet. Deepika, I think we'll have to ask him to come back again. Hello?
Yes, sir. Yes,
yeah,
sir.
yeah. We are really sorry for this. I can understand the plight of the participants, but we can't help it. And I think he has come back now, right?
Yes, sir. He joined.
Okay, Mr. Bassista, you can. Hello? Hello, Mr.
Yes.
Yeah.
Sorry.
Yeah.
Yes, sorry. It is happening repeatedly. It's monsoon.
No, it's not because sometimes it happens.
Okay.
You know. Yeah. Okay. Fine. Carry on. Hello.
So then once the site, yeah, I could,
Yeah,
you can hear me?
yeah,
No?
we can.
Okay, so the next step for this would be signaling. So we need to attach the segments. So there is example of A plus B component. We all know is an epoxy mixing machine. So it's better to employ a good mixer rather than hand mixing. Epoxy application safely apply the epoxy on both faces of the segment. Be careful, protect PT. Epoxy sent into PT can be very damaging for the tendons. So here an example of to avoid PT leakage. More advantages to be using center apply in these products. So then finally we can see epoxy squeezing after joining of the segment. Here you can see stressing of the temporary P bar, permanent PT bar. There could be sometimes application of permanent PT bars. Load transfer could be done once the epoxy has hardened. So here, in some stages, you would have definitely certain PT tendons. They may not get regular segments, but it could be after every few segments or number of segments, you may have a PT tendon to this. So here, PT tendon stressing and grouting. You can see and looping bridge the tendency sometimes because the cantilever of construction you need to progress it difficult to X, so it's better to grout them consciously. Yes, the of machine, colloidal machine, the grout, and then thing is done.
Okay.
Coming to Stakeable, fixing of carriages at the deck. You need to temporarily hold the deck edge because it's falling against gravity. So here's some explanation of how you could hold the anchorage and install. Site installation next, you wet the stay pipe together. So you need to make a stay pipe preparation. There's a special thing machine available to the stay pipes. Due to transportation limitation, you would only get maximum of 11 meters. Whereas you could install hundreds of meters long stay pipe, and so a welding procedure.
Yes, again, there's a bit of problem.
I
Yes.
think so. I mean,
Yeah, we don't have an alternative but to wait for him to come back.
yeah.
So that is a
He's
technology.
connecting back again quickly. There is
Yeah,
some
yeah.
interruption.
So he joined again.
Yeah, yeah. Hello?
Yeah, again.
Hello?
Yeah.
Hi, good. I'm back.
Yes, please.
So you have moved ahead with all the glitches, strand and boiler to pull strand. You could pre-cut the strand as required. Strand threading either by manually or by pusher. You could do pulley based strand threading. You could do use the pusher on longer stay cables. Here is an example of how the stays would be installed using a wooden reel. You could take it through the pulley, install the stay cables. So strand by strand installation method is the quite popular method that is being used for the stay cables, which is also being explained on this presentation. It offers connected to specific needs. absolute flexibility to adjust stakeable length during construction for variations in bridge geometry or changes to deck erection. No requirement of off-site prefabrication facilities like the large lock coil cables or other cables were used earlier, MSI cables. No significant additional construction loads on the structure as light and compact equipment is used. No additional requirement for use of tower cranes for cable erection reduces risk of delay. Lightweight shop prefabricated anchorages can be installed during deck and pylon construction, unlike the large clevis connection or large anchor nut that is cables. Strand stressing with monostrand jacks for positive increment is very handy. Improved site safety due to reduced component weight, simplified access arrangements. Strand by strand replacement during construction and during service is available. Minimum impact on bridge deck traffic for replacement. Single lane closure is typically enough to provide safe working for replacement of these stakeables. So here the SSI and stressing is in action. You could see the stages. Normally, you would have a two-stage stressing on these kinds of bridges. One is during the installation of the stage, erection of cantilever. Another one would be after application of SIDL, which is the fine tuning. There could be more stages depending on the complex nature of the bridge, long spans, whether the span has been erected before the main span. Many factors govern such stages. So here we see what is the theory behind strand by strand installation. So the idea is to calculate carefully how each strand will affect the other strand's stressing force. So here you see an example of as you keep increasing the strands, the force in other strands gets normalized or distributed. And so finally, you have to take into consideration the curve. And finally, you can achieve a uniform stress in all the stage strands which are installed actually strand by strand. So variance is normally achieved on site has to be between plus and minus 2.5% on completion. This is demonstrated by liftoff. Positive increment stress should be normally we are saying it's very handy. The handling is quite easy. This can be done for extras or medium span bridges. Negative stressing, which is detensioning of stay forces, shall be done through multi-jack. Below picture you can see for multi-jack. This type of stressing may be required for long span stakeable bridges where you presently erect sometimes with a high camber, and then you need to release your longest cable to reduce the force. As well as bring the deck to a required level. Handling and stressing of multi-jack is quite challenging and in handling and stressing. So it's quite challenging to use a large jack for this purpose of stressing. On concrete bridges, you would need wet joints at regular interval. So wet joints shall be adopted along in 30 to meter intervals. There are debates about it. Maximum maybe 50 to 60 meter, you should put a wet joint. This helps in breaking the line, allowing us a little bit of adjustment of the profile. The wet joint width could be 200 to 300 millimeter. Strong beams at the end of cantilever. Once the cantilever construction is completed, you would need a strong beam at the center of the cantilever tip to deflections of or to match the deflection of both the cantilevers. And before casting of the closure pour, you would need the strong beam to also help you to provide the jacking force which is necessary at the cantilever. So here an example of mid-span jacking. So you will need a mid-span jacking. This has to be done in case of a two pylon structure where you would need the main span to be under compression. So you provide an additional tension at the center. This puts the main span under compression always. And after that, you would cast this closure pour at the main span. The force could be designed as needed by the designer. The application of the force here, pictorial view, you could see could be positioned at certain locations depending on the force. Finally, you need a formwork, wet joint formwork. You need to interconnect all the PT. Once the PT is connected, you could pour concrete. Could be 1 meter in this case, the closure pour. Once the closure pour is done, we proceed with the SIDL, barricading work, bare casting, recasting. So at this stage, all the accessories are fitted, the black topping is done, the bridge is virtually complete, but it is not yet in the final profile. So based on the deck survey level, you go ahead with the fine tuning of some stage to achieve the desired profile of that particular state, of that particular stage, and of that particular time. All positive increment forces are applied by monojack. Negative adjustment shall be done by multi-jack. As you can see here, the fine tuning is done by a monojack. Here you can see a multi-jack photograph again. This you could use a large multi-jack for a negative adjustment if needed on a bridge. Finally, you have stakeable vibration to handle. So stakeables are prone to vibration due to dynamic wind loads acting on the cable. Vibration of stakeable are controlled to some limited extent by internal damping ratio of stakeable system itself and by some guide deviators that need that which I showed for taking any angular deviations introduced into the anchors. When these damping ratios are not sufficient, additional measures need to be taken to control vibration. So here the cable surface, so stay pipe shall be manufactured with double helical ribs on its external surface. This solution is efficient for rain and wind induced vibration. Below you can see on image A an example of such a stay pipe. External cross ties, these are connected between base and deck and they help to modify the period of vibration of the cable. This type is effective in case of transverse vibration. If carefully designed, longitudinally it gives little aesthetic reason and difficult accessibility for maintenance may lead to preference for other solutions when possible. Special damping device. Damping devices, many types are available: rubber, tensui, rubber dampers, friction dampers, hydraulic dampers. Aesthetic maintenance purpose, these dampers are installed near deck. Here below, image B, image C, you could see a damper, hydraulic damper. And then there is a friction damper, which is completely concealed inside the anti-vandalism pipe or the guide pipe. So once that is done, you come to the finishing works. So as you can see here, we need still to install certain protection devices, which are the guide deviator tension rings. As you can see, these will help protect deviations entering into the anchors. Once that, you would fill corrosion protection compound in the anchorage by vacuum method. Here the corrosion protection compound is being filled in the anchors. And if you are using saddles, then you have to fill the similar corrosion in saddles. Here's an example of how the saddle is filled with corrosion protection compound, and then the pipe is seen at the saddle location.
Hello, I think it's almost come to the conclusion. And again, I hope it's the last interruption of this internet instability. I think we'll just wait for him to come back for conclusion.
Yes, sir.
Yeah. Is he joining back?
Yes, sir, he is joining.
So meanwhile, by the time he joins.
Yeah, he joined, sir.
Okay, fine. Thank you. Yeah, Mr. Bassista.
Yeah, okay, sorry again. This would be the last time probably because I reached the conclusion, and as fate would have it,
Yeah.
as fate would have it, now it will never get disconnected. So now it would continue like that.
Yeah,
So
please.
now we come to the conclusion of this presentation. So we are looking at factors of affecting choice of erection scheme. It starts with the structural design, geometry, chosen method, type of superstructure. You need to understand the type of superstructure, repetitiveness of the scheme. Of course, you could look at the viability of special schemes and things like that. If they are repetitive, you need to spend depending on that. Time available, of course, cost is also a feature here, time and cost. Excess, you need to work out excess from below deck. These are very complex structures, so you can't limit to only these things. There would be many other possibilities. So that brings me towards the, so we have a end. So here is references and credits. Some of the slides that we used here, all the companies, all the people who are behind these wonderful projects that we presented here, and I'm proud to present my team here. It's always about teamwork, so I'm not alone. So I am supported by my colleagues here, Sumaya Sheikh, Shiva Kumar Balachandran, who has helped put together this whole presentation. So thank you. I apologize for this, which was not in my control today, but hopefully it would be better some other time.
Yeah, thank you. Thank you, Bassista, for an excellent presentation, but for the interruption of the technology, that is the internet connection, that is not in your hand. It is, you have explained everything, like that, all the nuances as well as the subtleties of the construction, including the erection, free-fan cantilever construction, balanced cantilever construction, both for the extradose bridge as well as the cable stay bridge. It's very, very interesting. And I again repeat, it would have been more interesting, but not for the interruptions. And before taking the questions, I'm sure that our panelists would like to add or complement your presentation with some of their words. I request Mr. Atul Bobe to say a few words about this presentation, and if he wants to add on some more points out of his experience of constructing cable stay as well as the extradose bridge. I know that recently he has completed that bridge there in Goa. That's a beautiful bridge, which I have seen that. And Mr. Bobe would like to add something.
Yeah, a couple of things. First of all, wonderful presentation. And like Mr. Hegde said, but for the interruptions that you had because of internet. But I think that's something that we have to live with. It's called the new normal, I guess. Interruptions of technology has become the new normal, so we have to accept that. But other than that, I think it was a wonderful exposition of cable-supported bridges. Couple of questions that come to my mind, of course, in addition to whatever you have said already. It would be nice and interesting to know, for me and for the attendees as well, I guess, how does one really select, because of the choice of cables that are now available, a plethora of cables that are available in the market. How does one select really, how do you make a choice between a saddle and an independent cable? I think that's one of the key questions that every designer and maybe even the construction engineers face when you really come to to designing the bridge. How do you make a choice between the saddle and any other cable between extra dose bridge and a cable stay bridge? That's the second question that comes to my mind, and that always, is at the back of my mind if I am designing either a extra dose or a cable stay. The third thing is what's the difference between a manufactured camber and a construction camber? You use both those words, and I would like to know what's the difference between these two. What's a manufactured camber and what's a construction camber? And of course, the fourth thing and the most interesting part for me is there's again a plethora of software where you can do camber control, or the geometric control as it is traditionally called. It's now called camber control. How do you really do that online? Because before the days of computers, you used to spend a lot of time using calculators to do camber control, and it was of course more complicated. Geometry control was more complicated. Now, of course, you have something like Sophistic, Midas, SAP, and so many other software where you could do that. But I think I would like to know if there's something that's online, which means that you don't really have to spend time doing those calculations, going back and forth between construction and design and waiting for the design engineer to really respond to the construction engineer and spend time going back and forth. Other than these questions, I think I'm sure there are 20 other questions that the participants have asked, and we will go to those as well. But these are some that come to my mind. And again, once again, I compliment you on the wonderful presentation that you made. Thank you. Thank you.
Bassista, I would like to take the questions. You have noted down the questions. There are plethora of questions.
I know.
Yeah, whenever you allow me to go at it, I will try my best.
Yeah.
Either now or after.
Now I think Mr. Bobe has asked some questions. Would like to answer that. They are noted down.
Yeah, I think. Yeah.
Yeah,
I could.
You can take those questions.
I could answer now.
Yes, please.
Okay, so sir has chosen a very wise and very difficult question also at the same time, which is the choice of Stakeable to be used. I think this is purely subjective question. There is no absolute answer to which system or which type you should use for one or another. However, there are definite advantages and disadvantages of certain system to be applied on a certain project or a certain situation or a certain scenario. So when we look at cable stay application or using of a saddle for a cable stay rather than a fixed and anchor block into a cable stay, there would be always a question of why would you go and use a saddle when traditionally the Stakeable has been built by anchor blocks or something. Here, one important feature is that saddles will be a bit more handy in comparison to using a steel box with the welded guide pipes and things like that, links or welded guide pipes into the structure. For a Stakeable application, I'm talking presently. Then we can come later to an extra dose where you have more choices whether the saddle should be a saddle or whether the saddle should be a link. Once we discuss on the Stakeable application, you could have both either a dead end anchor or a saddle. Saddle, definitely many people see it as a limitation as to how long you can go because there is a certain friction or a friction coefficient that you could use during construction and during service. Definitely that affects it. However, for a range of 200 meters, it is very effective because this allows you to erect the pylon with a much lighter crane in comparison to a steel box if you would embed into the structure. Steel box would need a larger accuracy off-site into a fabrication facility where to be surveyed and to make sure that this is connected. Connection of such steel box into the pylon would require high precision welding on site or connection if you would make it modular. Whereas saddles itself, by the way of putting it, they come in 2-3 tons of weight, easily erected by a smaller tower crane. As I showed in one of my slides, aligned you on site to the survey requirement using small screws on a support frame, and then you go. So different combinations. If again, the executioner's capability is very important to get that benefit. If you are going to get benefit out of putting a steel box into the pylon instead of using a saddle, then the executioner has to be very confident and comfortable of delivering it as promised onto that particular drawing. So that's also very important to see the comfort of the execution team to thereby handle such a complex, because it also translates into cost if something is not going to deliver on the site. Now coming to the second question on an extra dose bridge, whether you would use a saddle or a link. Again, a subjective decision. Designers around the world would be divided also, as is suppliers, on whether to go the saddle or the link way. Some companies have both. For example, some companies would have only one. So different ideologies, but this does impact the question of design, whether you find your pylon design getting a bit more aesthetic, bit more easier, bit more simpler by using one or another. Again, it's a subjective executioner's capability of putting together that kind of rebar, that kind of steel together. And also it is important to note that saddle would release a full cable. Saddle would release a full cable. Link would not release a full cable. The impact would be in the pylon. After 100% impact shall be in the pylon. You have to be very careful of the cracks which could come due to that impact to a certain range. So you need to shift that impact from the face of the pylon considerably inside for your rebar to act before you get that impact of crack or deformation of concrete around that due to the failure. In saddle's case, as you know, that saddle can hold up to a certain level of friction, and after that it will release. So one side failure would end into other side release of cable. Cost-wise, you can always say that I will have to replace a full cable instead of one side cable, but in practical, you could always understand as designer that in nutshell, you will have one for another. Coming to the manufactured camber versus the construction camber, your question on that. Manufactured camber, you could is something you could introduce into the manufacturing or into the construction. If I understand, on a steel beam, you could do it. On a precast concrete, you could introduce the camber during the construction. Construction camber, you could introduce on site as well. Many bridges are cast without any manufactured camber, and then they are provided camber on site. Here you could do with shims. Sometimes you could do with wet joints, this kind of camber, if it is only the first segment tilting rather than you are looking at the continuous slope or the profile. And finally, the question of software, it is very intriguing to find clear software that would help everybody. So a designer is looking at one particular answer. The execution guy is looking at another answer. The site guy is looking at the third answer. And finally, you have labor who has no idea about any of these softwares or things like that. So it's very important to integrate this. So what we showed here, a certain example, which can take the input of the designer as it is and present to a designer that, look, here we are comparable. Sometimes Sophistic or these companies which help the designer are not some forward integrating companies coming into construction. So then definitely sometimes you have to straddle over certain platforms to find another software which can help you. But the idea is to definitely conform technically or digitally. You could conform to all these three. Presently also, because of licensing and things like that, we find it very difficult to move the file from one to another platform. People have to take a printout and go in Excel sheet and try to combine. But request is on to these various suppliers to try and be more friendly to each other, to be able to handle each other's output files for people to live a better life. Huh? It's a quality of life getting affected, comparing those Excel sheets.
I think you have answered most of the questions of Mr. Bobe. It looks, I got, continuing with Mr. Bobe's question, in case of the links, especially for the extra dose bridge, instead of saddles, if you are using the links, perhaps I think you'll have to provide the additional 2 anchorages, right? at the end of the links.
Correct. That is also an additional feature. Yes.
So is it not an added cost? The cost will be more in case of the links compared to that of the saddles. Is that correct?
Correct. It is correct, but then you could also argue that the main tension element, that is the strand, is not
Yes.
straddling the pylon, so you reduce a little bit of the strand
Okay.
length passing through the pylon. So, but the maintenance wise or inspection wise, you could have this additional element.
Yeah.
Additional element and additional installation accuracy. As you say, number of bearings, whether you would like a number of bearings to be reduced on a project, then number of anchorages you should also try to reduce on a project.
Absolutely. That's one thing. The other thing is, I think manufactured camber, perhaps it is more suitable to the cast in situ construction rather than the precast, right?
Correct. It is, it is manufactured camber. You could do in most cases in situ construction is better. Precast, you would introduce the pre-camber into the structure. Into the precasting rather than wait for it later. It could result in a nightmare on erection side.
Okay. Now I'll come to the second panelist. Mr. Jatkar has an extensive experience in the cantilever construction, whether it's a free cantilever or the balanced cantilever. I think I would like to, if he wants to add on to the presentation of Bassista, he can. Mr. Jatkar, you want to add? Yeah.
Yeah. First of all, compliments for an excellent presentation, Mr. Bassista. You have covered all the aspects in great detail, but for your problems because of interruption. A general comment that anyway, for the past 2 decades or so, we are moving to increased mechanization, and more so now with a lot of mega projects coming up where the bridge lengths are 5 kilometers, 10 kilometers, and so on. And currently, because of the pandemic situation, anyway, we have to reduce the manpower. But the penalty is all the participants, right from the designer to the contractor, everybody has to move to a particular technical culture, which is the challenge now, I think. Recently, you could see some accidents at site because of failure of launching trusses and so on. So my general question is, VSL is a very renowned and one of the very few specialized contractors who do precasting and launching. So you have a great experience with you. So how do you take care of the quality assurance and control aspects, right from design of the erection equipment up to its implementation at site? So how do you see this process?
Mr. Bassista would like to take it right now?
Yeah.
Yeah.
Yes, I could. That could be. Yeah. So it's an interesting question. These are very risky equipment, quite dangerous. There has been multiple failures, as you can see internally. There is nobody immune to this kind of human errors or glitches or failures that could happen on such mechanized construction, as you put it. What we have done internally is we are working in strict coordination with all our offices. We have found now a global team of an expert committee where we call it an MEOP team. So major equipment operational permit. So there what we do is once we come across a major equipment anywhere in the world that needs to have a certain review and inspection and certain operational certification before such equipment can be operating. So this starts after this is not integrated approach. We continue to design the structure, we continue to manufacture the equipment, we continue to bring to site, and then finally at the site there are certain checks or certain hold points that we introduce to make sure the equipment is not operated before it has cleared all level of scrutiny. So to begin with design, it is very important to do a peer review or an ICE independent checking of an equipment before the equipment is getting into service for all aspects, whether it is wind, whether it is stability, whether it is cantilevering, whether it is loading, whether it is the dead load, live load combinations, tension, compression. All the design check must go through an ICE. That is what is checked and evaluated at that stage as well. Then manufacturing wise, we have a certain manufacturing document, quality control manufacturing document, which takes care of all the welding procedures or equipments or something. So the equipment is a piece of steel, but it comes with a 2000 or a 3000 page of document or electronic document, which gives you a certain understanding that it has been manufactured as per the required requirements, starting from the raw material testing all the way to the welding and then the load testing and deflections during the load test. Operational permit, we look into the people as well. So we are definitely qualifying our staff who can operate a certain level of an equipment. So we are also giving a certain permit system to staff, which is expiring every 6 months. So unless many construction sites, you would see that when we are getting busier, you change people. So today, one guy is operating an equipment, but he has to get transferred to some other site where is more needed. And then that equipment is handed over and certain glitch there or capability will lead to a certain accident or a failure as well. So there what we do is we have this system where it is printed and pasted on the equipment as to who can operate what. And if there is a change, then you have to undergo again a recertification process to make sure this is done properly. So the continuous culture, of course, we are not also immune. As I said, nobody has reached that level. We are trying our maximum with all these hold points and all these stuff that we are putting to secure and save our equipment, safeguard our people. Equipment you could replace, there is no replacement for a live man. So that's what is the philosophy behind all of this. So safety culture, using safely the equipment, ergonomically the equipment has been top priority now. I think the industry is also catching. We see now on the main contractor side, on other companies, this culture is catching up rapidly, and which is a very good sign. I think soon we should be progressing far better on that.
Okay, thank you, Bassista, for that wonderful answer. Now, I'll just go through some of the questions which is there in the question and answer box. I'll just filter which has been already answered. Mr. Chaudhary, Gajanan Chaudhary is asking whether there is any publication on the geometric control. Have you come across any publication on the geometric control, Mr. Bassista? Geometric
Google Baba, I don't know.
Casting
Maybe
curves.
we will.
Yeah, casting. If one has to, there are some publications available in Muller and Podny. Yeah, Podny he gives, and also Dr. Raina.
Correct.
Dr. V.K. Raina gives some guidelines on the casting curves as well as the geometric control. I think we can just go through that. And another interesting question Mr. Bassista.
I think Sean Muller has published also something. Sean Muller has done extensive work on this for long span bridges here.
Yes.
Correct.
Now, Mr. Chaudhary's another question is, what are the important consideration in the design and construction of accidental loss of segment during the lifting operation? Would you like to take it, or you want me to add to the...
This is your level. Maybe it's much better.
Now we have two construction people of equal stature.
See, advantages of having a mentor like Hegde sir here and Bobe sir here and yourself. So
you see,
please go ahead.
Yeah, I just want to answer that. There are certain guidelines in the codes which has been brought into this IRC 112 also for the cantilever construction when you are doing using a form traveler and doing the cantilever construction, whether it's a cast sensitive construction or you are handling the precast segments, there is a consideration has to be given for free fall of the segment which is being erected. That is the one, the self weight of the load has to be taken. It has to be considered during the construction as if the free fall at that particular segment weight plus, even the form traveler weight you have to assume that it's a free fall is taking place. That dynamics has to be considered in the design. But sometimes what happens, it's not very uncommon. The form traveler collapse is not very uncommon. It happens all over the world. It is not only the free fall. There could be a case. Now, Mr. Bassista explained how the farm traveler is anchored to the back segments. The segments previous already cut the segment. When the farm traveler is anchored to the previous segment, it has been anchored by the two or three bolts in the lateral direction, in the transfer direction. There could be a case one of the bolts or the anchor is giving away. The another bolt is still anchored to the deck. What happens in this case? The whole weight, say for example, the segment weight is around 100 ton. When it falls down, it gives a jerk. It is not a free fall of the segment. It is an impact which has been impacted on the cantilever. That impact force, the dynamics because of that is more than 3 to 4 times the dynamics of the free fall of the segment. That has not come into the code. It can happen. I think that is what sometimes happens, and we'll have to make sure that sort of things do not happen. I think only way to take care of it, that the proper quality control and quality assurance during the construction is made sure. But for the free fall of the segment, as for the farm traveler, there are codal guidelines. It is there in the ASTO, it's in the Eurocode. Now it is there in the IRC 112 also. It has been introduced. I hope Mr. Chaudhary is satisfied with my answer. I'll go to the further questions. Anchorages in pilot, how the choice is made between the alternative, that is steel anchorage box, anchorages is all. I think it has been answered in detail by Mr. Bassista. Is it mandatory to provide dampers for all the spans? I think it depends upon damping requirement. Basically, it depends upon the wind load which is coming on the structure, what sort of vibration is taking place. But anyway, I think he has explained already around the deviation, where the deviator block is there, some sort of a damper is provided. Mr. Bassista would like to take this question. Is it mandatory to provide dampers for all spans?
No, it is not mandatory. However, we have seen certain specifications from the conforming specification coming with requirements of damper. However, it is the designer who is in the best position to come up with the requirement for damping on a certain bridge. Yeah. So we have seen even stakeable bridges. Today, Bandra Worli, a large span bridge is standing without a damper. And then you could have a small bridges with dampers. So really, whether Bandra Worli should have a damper or not, anybody's guess, but really it doesn't have it. It is relying on certain cable ties, but you could see it's still standing. So yeah. I think cable vibration is quite a wide topic, quite and subject, yes. Quite subjective also. If you are mandatorily provisioning, like the large cable stay bridges which are coming, Basoli signature bridge, sir, you know it. It should already have specified dampers, so you work towards a certain frequency.
Yeah. May I add to this?
Yeah, please, Vinay.
You see, this Erasmus Bridge, Rotterdam in Holland, that was, I think, the first bridge which experienced vibrations after the bridge was opened. It has a span of 284 meters, steel deck. And when they opened the bridge, they found that after a while, when there was a medium density of rain and wind of a medium speed, the bridge started vibrating. And they had to really shut the bridge, introduce dampers, and then restart operations on the bridge. I think that was the time they first time realized that there is something called wind rain induced vibrations. And to control the vibrations, it's not necessary to only have dampers. You can have these cable ducts with the helical impression on top of it, which is some kind of a heaving up thing, in helical thing. Or you can have different surface materials of the cable. Roughness also helps in this. And damper is another solution. So there are many solutions which can be designed based on the requirement of a particular bridge and the given conditions of wind, etc. So I suppose, of course, Mr. Hector can confirm if that's the right answer.
Yeah, that answered the question. Now, there's a question from Mr. Pattiwar. I think it's a very interesting question, very important question. Does not strand bite happen when you restress or negative stress. That you said that, using the monostrand jack, you will be stressing twice. And also you said when there is a negative stress, that means to reduce the stress in the cables, you use the multi-strands. At the both the times, at the bite, it's a bite will it not take place if it is done at the same location? Is it allowed? That sort of question it is. I think Bassista, you can take that.
Yeah, so the rebiting of the strand, there are provisions as per design, as per the requirements from various designers. So positive increment. Let's go from the basic. So the bitten strand cannot be in the stakeable. So once bitten, it cannot be on the stakeable. It can only be behind the anchor block. That's the one clarification. Rebiting on the positive side, you can be only 50% rebiting of the wedge length. So for example, if the wedge is 40 millimeters long, as per the system that you are using, you will have to stress positively by minimum of 20 millimeter before you rebite the wedge. So this discussion happens between a designer and the stakeable supplier. What will be the effect of a certain stressing force? And so the stressing force has to definitely exceed more than 20 mm elongation of that strand for it to be positively rebiting on that strand. Now coming to de-stressing, negative adjustment. Negative adjustment is not done by disturbing the bite of the strand. You just move the entire anchor block from point A to point B by loosening a certain nut. So the rebiting does not feature as a part of a negative adjustment. So negative adjustment being done by a special jack, that is the multi-strand jack. This does not let you rebite the strand. This only lifts off the entire anchor block. So you don't lift off all the wedges when you are installing a multi-strand jack. You lift off the entire anchor block. You loosen a little bit the nut and you release the entire anchor block back. So the wedge biting has never been disturbed on a negative increment.
Very good. And another interesting question from Yogesh Vaingankar. Due to variation of ambient temperature of different times at different time of the day, the deck levels changes substantially, which will obviously affect the cable forces. How it is considered in calculation of the strand by strand installation forces?
Very interesting question.
Yeah.
Okay, so this is answer could be shared here. Of course, I see many smiling faces. They know also the answer to this, and they have to actually contribute after whatever I will put today. So just now, so what happens on what happens on this particular feature is that this is the stage by stage construction. So you define all your stages. And your model is capable of running all stages to know the forces in individual cable at all stages. Then once you have individual forces, you have the individual force in each strand as well, because the forces in strands don't vary more than plus or minus 2.5%. The thermal effect in this case, I don't think is considered important, because at the end of the day, this is something which is of transient nature. So it's coming, it's going, it's coming, it's going till the day you close it, and then it's the final effect. So during construction, I don't think this will play an important role as to force in the stakeable. What is important is to define the final stage of construction, to remain within that and to reach it within the limitation which is there, which is the stage by stage construction of this cable.
Yeah, thank you.
Up to you, sir. Now,
yeah, thank you, Mr. Bassista. I think we have overshot the time already, and most of the important questions have been already answered. That I believe I've just filled through the question and answer box over here. And before handing it over to the organizers, I want to thank you once again. And also, I request the organizer, though it's a little bit of burden to Mr. Bassista, if it is possible for you to re-record it, and upload on the IIB this one, because there were a lot of interruptions and the presentation was it could have been more enjoyable and more clarity could have been there if the organizers as well as Mr. Bassista thinks it is possible to re-record it and upload it on the website of the IIB, and all the participants, including myself, will be very happy to to go through it once again. And with this, I will hand over this virtual dais to the organizers, please.
Thank you very much, sir. I will take it to the next. It was a great presentation and interesting question answer session. A lot of questions are being put up and answered. So I'll just move on to the next part, vote of thanks. So yeah, Ruhi, can you just put up the slide, please? Yeah. So may I now request our joint honorary secretary, Dr. Gopal Rai, to propose vote of thanks. So let me introduce him first. Dr. Gopal Rai holds a PhD from IIT Bombay. His phenomenal level of prowess has enabled him to be associated with several prestigious projects, including the Apsara reactor BARC, Mumbai Airport, bridge strengthening of Mithi River, ASIC hospitals, JNPT, ROB Bridge, and many more. He is Honorary Secretary of IIB, General Secretary of Association of Structural Rehabilitation and Retrofitting, Committee Member of ISSC, Mumbai Center, BIS and ACI. He has delivered 680 presentations nationwide and 27 presentations in international conferences. He is also a keynote speaker and author in 4 international conferences and more than 10 national conferences. Dr. Gopal Rai has a colossal research profile as well. More than 100 number of his research papers have been published in journals. Dr. Gopal Rai got the award for 50 manufacturing innovative leaders at World Innovative Congress Award 2019. Also in Dubai for 40 most influential leaders under 40 years 2017-18 by Asia One and many more. With this introduction, let me invite Dr. Gopal Rai to propose vote of thanks. Gopal, over.
Thank you, Swapnil. Thank you for a brief introduction. Let me go to the, after a lot of stresses in the cable, thoda light moment hona chahiye. Little light moment should be there. तो मुझे वो इंजीनियरिंग की एक शायरी याद आ गई जो हम लोग इंजीनियरिंग में पढ़ते थे कि हमें तो कंक्रीट ने लूटा, रेनफोर्समेंट में कहाँ दम था. हमें तो कंक्रीट ने लूटा, रेनफोर्समेंट में कहाँ दम था. ब्रिज में क्रैक वहीं पड़ी जहां वाटर सीमेंट रेशियो कम था.
वाह वाह, क्या बात है.
ठीक है, तो मतलब थोड़ा लाइट मोमेंट होना चाहिए. स्ट्रेसेस आर टू मच स्ट्रेसेस इन द केबल. थैंक यू सर. तो इनफैक्ट सिविल इंजीनियरिंग में जीएफ मतलब ग्राउंड फ्लोर होता है, क्योंकि सिविल इंजीनियर और ब्रिज इंजीनियर GF means ground floor. So that is a short form for civil engineer. So with this word, first of all, I request for the, as this is lecture series, we are coming up with the next lecture series. So I request Ruhi to please display before I give a vote of thanks. And I request our president to display the next lecture series. Yes, over to Vinay Gupta sir, to you.
Yes, thank you, Gopal. So friends, first of all, let me compliment Mr. Kailash Bassista. I was hearing all through, and of course you also were. And of course, some of you I know have complained of the voice quality and all that. And now let's see how recordings and all can be given. But the kind of speech he had, it is like he's standing at the site of the same bridge and telling you from there what you should do. How cables move, how stressing is done, how the cable would look like, everything is from his heart and everything is from a very live angle of his work that he has done. I have known this calm and quiet gentleman for the last about 15 years. And of course, VSL all the time. And one knew that he had a good knowledge, but didn't know that he'll become the MD of this VSL India. And he has quietly attained that position. So thank you, Mr. Bassista, and my compliments to you.
Okay, sir.
Friends, our trial normally is to bring, I mean, of course, we have also learned through the times of this COVID, etc. So our trial is to bring from the comforts of everyone's home speakers who share their experiences, and we all get enrich our knowledge. And at the same time, we also try to see everyone's question is answered. In fact, in some of the peak times, we had 1 hour lecture and 1 hour of questions. Even we have gone to that extent, so that it's more like a lecture come workshop and not like a conference or a seminar where somebody comes, delivers and goes. No, here he makes a presentation, he or she, and then you have enough interaction. Although I understand that there is certain distance that is maintained because we are not able to see you, you are not able to sort of speak out very much, and times are always in short supply. But still, idea is you put your question in the question answer box and then have everything replied more or less. And beyond that, you are free to write emails to question further. This also helps us that since we are doing on the e-platform, it's easy to get a speaker. The speaker wouldn't say, oh, sorry, that day I'm busy, I have a meeting and this and that. Even you are also available. We just program it. And the time we choose is something when we have finished the main part of the day-to-day activity of the work, and therefore 5 o'clock. And 5 to 7 suits the foreigners also very much, especially from Western side. So this time I had a telephonic call with the Dr. Edmund Booth, who is a part of Eurocode 8 committee. He is the one who prepared along with the others the first code, part 1 of Eurocode 8. And I think Mr. Hegde and some of these people who are here will be knowing him. We had him in India, in Delhi, in way back in 2008 or something. And then I contacted him now, and he remembered everything. And more than everything, we, us, and all that, he remembered the country so very well. And the kind of email he wrote to me, I wanted to tell you, for which we'll have because from whom we'll have a lecture on the next Friday. He said, look, Mr. Vinay Gupta, I was there with you. I remember it very much. And I also remember that you had sent me to Taj Mahal. But perhaps that was not the right time, because that time I was in affair, but I did not have my fiancée with me. And 1 month after I returned from India, I married to my fiancée. 10 years ago, he was about 61. So, person is so live, so healthy, so young, so energetic at the age of 71 or 72 now, that he's agreed that yes, no problem. And he's also agreed that when the time permits and when things improve, he will come to India, and this time along with fiancée, and go to Taj Mahal with fiancée. So he's very kindly agreed to deliver this lecture on the next Friday. You will see all the details on the screen on seismic design of bridges and structures. He was the main creator, one of the main creators, but of course the main creator I know of the part 1 of Eurocode 8, which is earthquake engineering. But he also has done some work on bridges. So we said, fine, he is the right person, because in the earthquake engineering, we all know that earthquake begins from general, and general applies to all kinds of structures. Bridges are one of those. So he would be taking care of both these aspects, earthquake in general and on bridges, how to apply. So I think we'll have the right kind of a speaker. And of course, we have Professor Mahesh Tandon, I myself, both of us from the same organization will be there live with you. And of course, you see the rest. So please come, please join, and please make this a success. Thank you so much for your patience. Yes, over to
Thank you,
Dr.
sir.
Gopal Rai.
Thank you, sir, for a brief introduction of the upcoming event. Now, let me give a formal vote of thanks. As a role given to me, let me thank first of all to our speaker, कैलाश जी. कैलाश जी के लिए अगर कैलाश जी ने एक भी शब्द हिंदी यूज नहीं किया, लेकिन मैं हिंदी उनको मतलब अगर समझ रहे होंगे तो एक उनके लिए, रोना जिसकी फितरत नहीं, संघर्ष उसकी आदत हो, कामयाबी की बुलंदियों को हासिल करना जिसकी चाहत हो. All the best for you at the young age.
माशाल्लाह, क्या बात है.
ठीक है, तो मतलब कैलाश जी आपके लिए you have we are bored with cement, concrete, aggregate and water and chemical. The new element you are introducing is cable, which is stressed. Okay, so congratulations to you, and really you have covered very nicely. Thanks to you. We request that VSL will keep on supporting all the IAB events and all and everything, and you will share always your upcoming the solved projects you will share with us in the IAB forum. Thank you very much, sir. And we request on behalf of audience and behalf of organizing committee, if you can formally send a video, okay, so we can put on our website so that whatever कोई भी सिविल इंजीनियर में कोई काम ऐसा हो ही नहीं सकता कि जिसमें रुकावट ना है, लेकिन रुकावटों के बाद जो आनंद मिलता है, जो सक्सेस मिलता है, उसका आनंद अलग होता है. So we'll treat that this is a trailer, but the final video will get on website within say 2-3 days. So I request on behalf of audience that you should share the video with us, and we'll put on website for a month so that people can refer that. Thank you very much. Next, thanks to our guru or my mentor, Sri V.N. Hegde ji, the moderator of the today's event. Very nicely in a tough situation, sir, doing an adverse condition, you have handled the situation and in a very well. And Atul sir se kam smile aapki nahi thi. Okay, so with that is a gesture. Thank you very much, sir, for handling such a tough situation. We have also learned when the internet lost how to handle the situation. I have learned from you. Thank you very much for giving us sparing your time. Now, let me thanks to our panelist, Engineer Mohan Jatkar ji. Yes, also the executive committee of IIB, and he has a vast experience in the bridge execution and from the contracting part. Really, thanks for your valuable comment. Now, Atul Bhoveji, really, when we see the bridges in Goa or like some cable stay bridges, which is designed, lot of cables, now I can understand the physics and chemistry and the questions you have asked behind that. Thank you very much for giving your valuable time and suggestion, and also motivating our young brigadier of IIB, as this is all you have planted the tree and just we are putting some little water and we all are enjoying the fruits of IIB. Thanks to Bide sir. Thank you, Atul Bobeji. Now let me thanks to our Director General, Engineer Duteji. Thanks for guiding and helping us and encouraging. The topmost is always saying, yes, we can do it. Hum log karenge. So this is the word encouraged by Bide Sahab also, and now you are also encouraging us so that we are taking IIB to the next level. Now our own president, Engineer Vinay Gupta ji, all stalwarts, all speaker, all everything. Okay, just we are just following the instruction and we are trying to cover all the things, but the brain is only the president who is handling and who is helping the IIB to grow in a higher and higher. Thank you, Vinay Gupta ji, as a president of IIB. My colleague, Engineer Swapnil Joshi, really thanks for giving a valuable talk and also handling the IIB platform, and keep doing. Thanks to Deepika, who is a colleague of Swapnil from Intento. Thanks to Ruhi as a coordinator of IIB. Thanks to Daksh Solution for handling the website portal part. Also, I think Vinay Gupta ji has already explained the forthcoming event of on 14th of August. So आजादी के पहले हम लोग ब्रिजेस को सेव कर लेते हैं from earthquake. So I request all कि before we go for celebration of Independence Day, let us save our bridge from another big force or big lateral force which come and damages our bridge. So with this note, I thanks to all, and keep becoming a member of IIB, and keep referring. If once you become a member, you can refer. Now earlier 27,000. Now we have in last 3 months we have uploaded another 1,700 more technical paper. So now it is 28,700 papers are there. Papers are there once you become a member, and you can refer that. You can also become a corporate member. So with this note, we conclude this today's the webinar. And thanks to all committee member, and we'll look on 14th of August.
Thank you very much.
Thanks to you,
Gopal,
Gopal.
before you end your vote of thanks, I
Yes,
will
sir.
also like to convey my sincere thanks to these two women, Ruhi Agrawal, who has been coordinating behind the curtain. And please remember that they are very important, and without them, the things don't move. And the other person who is equally well responsible for this, handling the show behind curtain, is Deepika Singh. And at the same time, our IT expert, Mr. Josefa, who you see, I am seeing at the bottom of my screen, but maybe you see somewhere else, has also sort of put everything together. And he has trained us how to use this platform and finally make everything happen almost uninterruptedly. But my request to Mr. Bassista is that please convey that video recording. And next time, we'll like to have you once again with your practical experience, but please try and improve your internet.
Yes. I think I should try to, as I said, till the time the presentation is there will be glitches. And then the technology is such that after that, never happened again. So you can see how it works.
Thank you so much.
Once the cable is
So just
stressed,
joking.
so once the cable is stressed, you have to believe him. It's done, sir.
I think Mr. Bassista has stressed his cables and relieved us of the tensions. They have taken the tensions now.
Thank you. Thank
Okay,
you
sir.
very much.
Thank you.
Thank you so much.
Close.
Thanks,
Thanks,
everyone.
everybody.
Thanks.
Thank you, sir. Thank you.
Thank you, sir.
Sir, should I end now?
You can close the meeting. Yeah,
Okay, bye, sir. Thank you.